Hi students, in this lecture I am going to discuss problems based on intensity of gravitational field and variation of G. Let us see first one. So two bodies of masses m1, m2 moving in circular paths about their common center of mass due to their mutual gravitational force of attraction. Find their time period of revolution. So they are moving about their common center of mass, right? See how to solve it. So let us take 2 point masses. If we have 2 point masses m1 and m2, suppose separation is d. Okay. Then distance of center of mass from m1, take it as r1, and that from m2, take it as r2. Then r1 is equal to m2 d by m1 plus m2, right? This is what we have learned in center of mass, right? And R2 equal to, it is m1 d by m1 plus m2. Now see what happens. M1, by taking center of mass as center, it revolves in circular path like this, right? And m2 about same center of mass. Let us make a diagram separately. Suppose this is the first one, m1, and this is m2. Suppose this is now center of mass. Okay. That means now m1 revolves around this center of mass. Let us see how diagram is. It comes like this circular motion, and coming to m2, about same center of mass. Let us extend the line. This is center. So like this, okay. So this is m1 and this is m2. And if you observe, they will be always on same line at any point of time. That means suppose m1 is here at one instant. If this is m1, m2 will be, if you draw a line passing through center, m2 will be at this position. So separation between them always is same. They will be always on same line. That means m1, m2 and center of mass C. These three will be always on same line. That means if m1 completes one revolution, m2 also completes one revolution. That means even though they have different radii, but time period will be same. I am repeating, even though they have different radii, time period will be same. Okay. Now that is what we have to calculate. And here key point is, whenever a body moves in circular path, so we have to focus who is providing centripetal force. So it is now gravitational force between them, right? Let us say we are focusing m1. We are focusing m1, then gravitational force G, m1, m2, If separation is d by d square, gravitational force is a providing centripetal force g m1 m2 by d square, that is equal to, if we are focusing m1, it is m1 into r omega square. R means it is r1. Okay, it is r1, and that value how much means r1 value m2 d by m1 plus m2. So m1 r1 omega square. Okay, then see here m1 m2 m1 m2 gets cancelled, right? And g coming to here becomes d, becomes d cube. That means omega square equal to, or directly take omega equal to square root of, see what else left here, omega square g into m1 plus m2 upon d cube. Okay, this is omega value, which is equal to, 2 pi by t. That means now time period is t equal to 2 pi root d cube upon g into m1 plus m2. That is now time period of revolution. We can get same thing by taking force per second body. See how equation is coming to centripetal force, no change. It is g m1 m2 upon d square, that is equal to, if you are focusing m2, it is m2. We have to take r2. R2 means m1 d by m1 plus m2. m2 r2 omega square. So once again we get the same answer. So both have same time periods. Okay. So here only changes that m1 is having less radius, that means having less speed, because we are knowing that v equal to r into omega, right? Omega same for both. So r is more means speed will be more. That means for m1 speed is less, m2 speed is more. Okay, that's why both having same time period, right? See next problem. Find in what ratio a body of mass m should be divided so that for a given distance the magnitude of gravitational force of attraction is maximum. So we have divided now a given body of mass m into two parts so that for a given distance force of attraction becomes maximum. Then see, so its mass is m. We are dividing into two parts. Let us say it is small m, and remaining one is now capital M minus small m. Now between these two, force of attraction modulus value I am focusing g m1 m2 by d square. Okay, and condition for a given distance, so d value fixed. Now in this only variable is a small m, and to make this maximum we have to differentiate force with respect to variable and making that equal to 0. So this is what we have learned in maxima and minima, right? See derivative of that, anyhow g constant, d constant. So I am taking now directly derivative of m into m minus m, that is equal to 0. Now see this becomes how much? It becomes m minus 2m equal to 0. Therefore m equal to how much? It is m by 2. So we have to divide that into two equal parts. Then that force becomes maximum. Okay. See next one. An infinite number of particles, each of mass m, are placed on negative x-axis at distances 1 meter, 2 meter, 4 meter and 8 meter and so on from the origin. So we are given here distances. Find the magnitude of the resultant gravitational force acting on a particle of mass m placed at origin. Okay. So we have to find gravitational force. Let us see. Given how much each of mass capital M, distances 1, 2, 4, 8 and so on. Right. So it is now. Let us take this is x-axis and this is now origin x equal to 0. We are keeping it x is equal to 1, 2, 4, 8 and so on negative x-axis. In fact, here is it negative x-axis or positive x-axis? That is not important because we are focusing on what is a modulus of the force. Okay. Then force will be equal to G M M distance of the first one from origin. It is 1. So it is 1 by 1 square. Okay. Second one, it is 1 by 2 square. Next one, 1 by 4 square. Next 1 by 8 square and so on. Okay. See carefully. G M1 M2 by 1 by D square. Next 2 square and so on. So this calculation becomes how much? G M1 M2 1 plus 1 by 4 plus 1 by 16 and so on. Right? Now for this one, if you are taking up to infinity and this value is equal to, I am writing here. So I think you are knowing this one. Sum of infinite numbers, right? This is equal to a by 1 minus r, where a is the first term and r is a common ratio. Then this becomes g m m. First one it is 1 by 1 minus common ratio. First and second 1 by 4 and next again 1 by 4 and so on. So 1 minus 1 by 4. Okay. That means now this is equal to how much? 4 by 3 g m m. Okay. That is a final answer. Right. It is very simple one. See next one. Find the time period of rotation of the Earth so that an object at the equator becomes weightlessness. Okay. So we have to find time period of rotation. Weightlessness means G value should become 0, right? So we are knowing that how G value changing with latitude, that is G5 equal to G minus R omega square cos square phi, right? Now he's asking at equator, that means a phi value equal to 0, right? That means G5 that is equal to how much? G minus R omega square. So if an object is becoming weightlessness, its meaning is at that place g value becoming zero. It is not mass because mass is a constant. That means see for what value of omega this becomes zero. So from this omega equal to root of g by r. Okay. Then time period is t equal to 2 pi by omega. Substitute there 2 pi root of r by g. Okay. Now in this you can substitute the value of radius of earth and acceleration due to gravity. Okay. Let's see next one. Find the height at which acceleration due to gravity becomes g by 16, where g is acceleration due to gravity on the surface of the earth. If r is radius of the earth, that means we have to find the height in terms of r. So it becomes g by 16. So this question we can solve directly. Becomes g by 16. With the height g value, it is equal to g into r by r plus h whole square. It becomes now g by 16. So it is now g by 16 equal to g into r by r plus h whole square. G cancels. So 1 by 4, or you can say from here 4r equal to r plus h, right? See once 1 by 4 equal to r by r plus h. So 4r equal to r plus h. That implies h equal to 3r. So it is a very simple question. See next problem. Find the height above the surface of the earth where acceleration due to gravity becomes 64% of that on the earth. It is again same as the previous question, right? Okay, I will do that. It becomes 64%. Become 64% means again same relation. GH is equal to G into R by R plus H whole square. It is now 64%. That means 64 by 100 into G, right? That is equal to G into R by R plus H whole square. G gets cancelled. Now it is becoming 8 by 10. That is equal to R by R plus H. Or you can say it is now 2 4 times, or this is now 5 times. That implies 5r equal to 4r, 4r plus 4h, right? That implies h equal to 5r minus 4r. It is now r by 4. Okay. It is directly we can get it. Right. Then see next one. If a body if a body is taken to a depth of 32 km, then find the percentage change in the weight of the body. So weight changing means G value changing. So how much percent G value changing? That is what we have to focus. Taken to 32 km, right? 32 km means the relation what we got. Relation with the depth. G suffix D, that is equal to G into 1 minus D by R. Okay. By what percent? That means we have to calculate now G value because mass is a constant. Distance given how much? 32, right? So this is now 32 means change how much? Focus first of all. G minus GD. To find percentage change, we have to focus final value. So it is G minus GD by G. So this is how much? G minus GD by G is equal to D by R. And if you want percentage, multiply with 100, okay, into 100, right? Then see how much we get. D value given 32 kilometer, and this is 6400 km into 100. Two zeros gets cancelled. This is 1 by 2. Means this is a half percent. Means if you are taking to a depth of 32 km, weight changes by half percent, or you can say weight decreases by half percent. Okay.